Hi everyone, so this is going to be a walkthrough of what you should expect from your first Oxford AQA 9210 Comp Sci mock exam taking place in April. So as you enter the room, this will already be set up for you. This is your electronic answer document, open in Word, so you'll need to type your answers and also paste screenshots here using the snipping tool. The other things you'll have is you will have a printout of the question paper and a digital copy if you would like to look at it there, but maybe it will be good to look at the printed copy. And then, of course, a copy of the skeleton code. So this is not the same one you're going to do for your exam. I'm just going to use this as an example. And this is the first time I've looked at this code, so I might not know some of the answers straight away. So let's get into it. So first of all, section A, and you're advised to spend no longer than 30 minutes on this question. This is the non-programming section. Okay, so first question, 1.1. I'm looking for two variables of Boolean values. So what I might do here is search for values of true or false. So I can see here I've got a function called decide winner of round. So because it returns true or false, that must mean when it is called, the variable that it's assigned to, which is this one, player one wins, must be a Boolean type. So it will be true if player one has won, and it will be false if the other player two has won. So two-player card game, that's what this pre-release is about. So I'm going to type that in. And then I can also see here there's an assignment taking place with a true value. So player one turn must also be a Boolean value. So look at the next question. So we're looking for a subroutine that returns a string. So let's go back into the code. You can see that this routine here is a procedure. It's not got a return value. This one returns Boolean, and we found one. So because this returns the result of the input function, and there's no int being used, there's no typecasting function, no conversion, we can see that this variable choice must be a string. So and a possible answer to that is the get card choice subroutine. Let's look at the next one. Explain why subroutines often use parameters. So to answer this question, you need to think, well, if you don't have parameters, then what will the routine have access to? So you have to have the data coming into the function or coming into the procedure in order to be able to use it. So you might say something like a subroutine must have parameters so it can accept the data being passed in when called. Yeah, let's leave it as that. Is it a 2-mark question? So we might need to give another answer. So the reason is if we have variables and subroutines, again, we might not have learned this in much detail, but it also allows for what's called generalization. A subroutine using parameters will be reusable and have one block of code suitable for more than one task or something like that, or more than one job. That's a good thing. Okay, so let's look at 1.4. Describe the data structure that has been used for the variable deck. So we can see deck is assigned down here, and it's a card game. So normally in cards you have clubs and spades and diamonds and hearts. So in this game there's different suits. They're called the suits. But the other thing, the rank, the number of the card works the same. So when I describe deck, what is this? This is a Python list, or like I said, the example would want you to use this word array of strings. You might say each string is one card, suit, and rank, or something like that. So whilst we call it list in Python, we need to use the term array in the exam. Okay, so the decide winner of round subroutine uses a selection structure to work out which player has won the current round. Figure 1 shows a pseudocode version of the third selection statement in decide winner of round. Else if player. So what we're going to need to do now is we're going to need to search for this code in the Python version, so to see if we can get a little bit of an understanding of how it works. So in Python, I would need to use a double equals for this. Okay, so we're inside the function that it describes. So this game is like a comparing card game, and we first check that if the players have drawn, as in, so it's top trumps, so it's like who's got the higher suit of card. So in the first case, if you've got the same suit, then we need to look at the ranks. So it depends on who's got the higher rank. So either player one has, if you've got matching suits, then either player one has the higher rank, or player two has the higher rank, player one has the lower rank. So if neither of those things are true, then what must be the case is that one player has the trump card because they're not the same. Or it could mean, I guess, that the ranks are the same, but then I guess we still, seems like we favor player one or something. So anyway, let's write that up. Again, you will have much longer to kind of understand your code. You will have 5 months before your final exam. So don't worry if some of this seems confusing. You don't know about how this game works. I'm just making a series of assumptions having played and programmed games like this before. So what was the question? Let's go back. Explain what must have happened in the round if the condition in the third selection statement in decide winner of round is executed and evaluates to true. Okay, let's say so. So we're just going to describe the rules that must have been false. So players had the same suit. If the players had the same suit, player one did not have a higher card. If the players had the same suit, player two did not have a higher ranked card. I should say higher ranked card. And what this means is player one's suit is Pox, which I guess is the trump suit. Let's put the trump suit. So it's just the terminology of a card game, just like we had to learn a series of words to do with encryption for your task. Don't worry if you don't know some of these particular card game terms like suit and trump and rank. Okay, let's look at the next question. 1.6. Okay, we've got some pseudocode inside the shuffle deck subroutine. And okay, can immediately see. So this is similar to what we learned just last week at the time of recording this video. We were learning about a swapping algorithm. And a swapping algorithm, if you do it with a list or an array, it needs a temporary variable. So it needs temp. So the reason this won't work is, let's have a look in idle for this. If I've got, so let's say I've just got a list of, or an array of 2 spaces. And let's say my pos1 is just 0 and my pos2 is 1. And let's say at pos1, I've got 77. And at pos2, which is the second position, I've got 99. If we try and swap them like this, whoops, if we try and swap them like this, I want you to see what happens. Dec at pos1, or let's start with pos2, becomes dec at pos1. What does that do? It copies pos1 over pos2. Now we're going to do dec at pos1 equals dec at pos2. What does that? Well, it copies pos2 over pos1. So the first one copied pos1 over pos2. The second one copied pos2 over pos1. What's in the deck now? Can you see I've now got the same card? So I took 77 and I overwrote pos2. Now what is pos2? Pos2 is 77, so I overwrote pos1. So I just end up with a duplication of the same card. So what I'd write here is not possible to swap without using a third temporary variable. The 2 cards would end up having the same value. Okay, let's have a look. The next question. The iterative structure while loop in the get number of cards hand subroutine makes use of the value cards in hand. Make sure that the value of cards in hand is less than 14. The maximum value allowed for cards in hand can be altered by changing the condition of this iterative structure. So let's do a search for that in the code so we can see where that is. So it's called, where the routine is. So here we've got Python is exclusive, so this would be 2 up to 13, but not including 14. So the question is, why is it that this can go up to, sorry, the question paper, why is it that this can go up to 26 but not 27? And this is to do with the playing cards. If you know anything about card games, you will know that if I actually have my full deck, not just for this example, what is the len of a deck of cards? Only 52. So whilst 26 is allowed, this would mean each player has half of the deck. We could not have one player having 27 cards, because this would mean the other player wouldn't be able to have the same amount of cards. So let's put that in our answer. So the deck only contains 52 cards. 26 is allowed, as 2 times 26 equals 52. Any more cards would mean there are not enough cards for both players to have the same number. Let me change that, it's not very good English. Any higher, and this would mean that there would be not enough cards for both players to have the same number. Perfect. Okay, we finished question 1. Excellent. So I think in the next video, we're going to look at question 2.